All right, so now we're going to go ahead and we're going to add rational expressions that are a little bit more complicated. And in that, we have some binomials and some trinomials. So there's going to be a little bit more complicated work to this, okay? But remember, it goes back to that main thing that we need to do. And that is the first main thing is number one, common denominator. And that is the case for any time we add fractions and expressions. So in number 3, you'll notice that automatically we have common denominator, which is 2m minus 1. Both of them are occurring. So when we do that, we just go ahead and make a big old fraction. We say, okay, well, we've got 2m minus 1. We have met the common denominator piece. Now, once we go to the second part is like, let's work with the numerator, because we've already accomplished the denominator. So I'm going to circle the entire numerator and I'm going to bring it out. And it says m plus 2 plus, and notice it's addition. Okay, I've got to grab that, 3m minus 3. Okay, and because it's addition, nothing actually happens to this numerator right here. It actually just all stays as m plus 2 plus 3m minus 3. Okay. What I like to do is I like to bring the numerator off to the side, and I like to work with that on its own, okay? And when I do that, number 2 is essentially collect common terms, okay? So collect our common terms. And those common terms are, for example, m plus 3m. Well, what is m plus 3m? Well, I know that that is 4m. Okay, this and this, the m and 3m are common, and 2 minus 3, which is minus 1. Okay, which is minus 1. And what I'm just going to simply write now is I'm going to say, okay, well, I have 4m minus 1 over 2m minus 1. Now, the one thing I'm going to do at this point is number 3, find out if there's a common factor we can divide. Okay, so I like to factor. And then once I have things factored, or I like to go into the simplifying process. Okay. Well, 4m minus 1, nothing can factor out of that. It's not a quadratic that's easily factorable. In fact, it's not a quadratic at all. Okay. And both the 4m minus 1 and the 2m minus 1 don't have a common factor. So I think that 4m minus 1 divided by 2m minus 1 is going to be our answer. There is no common factor at all, and it's not a quadratic that needs to be factored. So I'm going to go ahead and check my work. And when I check that work, what I'm going to do is I'm going to type in the original equation. It's already posted over there. Remember that we have to type in x's, okay? And then what I'm going to do is I'm going to type in the answer that I have. So 4x minus 1 divided by 2x minus 1. And you will notice that they overlap. Now, because they overlap, they are equivalent to each other. Okay, so these guys right here are equivalent. And that means their answers are essentially the same. And that means we have simplified this down as far as we can in this case. Okay, so that tells us we're correct. In the assignment, you're going to be doing a screen snip of the graph and the equations and plugging it right in while showing your work. Let's go to the second one, and we are going to see what we can do with this one. All right, so this one is the exact same, except you'll notice that there is a quadratic in the denominator. So it says x squared plus 6x plus 5. X squared plus 6x plus 5. That is going to go into the denominator, plus 6x plus 5. Okay, and then what I'm going to do is I'm going to circle that numerator, and I'm going to bring that out. Now, here's the tricky part about this one. 6x plus 3 minus, there's a minus in there, x minus 2. Now, notice in the previous problem, I still put it in parentheses. I still need to put this in parentheses as well. Okay, that second piece. And the reason why that's so important is because that negative affects the x minus 2. It's saying it is the opposite of x minus 2. Now, just like in the last problem, I'm going to bring the numerator down, and I'm going to work with that independently for a second. So 6x plus 3 minus x minus 2. And what I'm going to do is I'm going to distribute those negatives. So 6x plus 3 that x becomes a negative x, and that negative 2 becomes a positive 2. Now, remember in my steps earlier, I said simply collect common terms. Okay, so I do that. 6x minus x is 5x. Okay, 3 plus 2 is 5. Okay, and then what I'm going to do is I'm going to rewrite everything. So 5x plus 5 over x squared plus 6x plus 5. Now, here's the tricky part with this one. I have to go back to my steps because my steps simply say factor and simplify. So I look at it, can I factor 5x plus 5, and can I factor x squared plus x squared plus 6x plus 5? So if I look at 5x plus 5 right here, yeah, both of those have a common factor of 5. So I can say 5x plus 5 is the same thing as 5x plus 1. If you didn't know that, okay, if you didn't quite know that, I could factor it by using Desmos, right? So I could say 5x plus 5. I look for the intercept, which is -1. And remember, when the x-intercept is -1, I write x plus 1. And then, of course, there is the a value that needs to be thrown, or the vertical or the stretch, or in this case, the slope of this line that needs to be plugged in there, okay? Then I'm going to factor x squared plus 6x plus 5. And remember, that is simply two numbers that multiply to 5 and add to 6. Okay, so two numbers that multiply to 5 would be 1 and 5. And 1 plus 5 is 6. So it would be x plus 5 and x plus 1. Once again, if you did not know that, I'm going to use Desmos to prove it. I'm going to type in x squared plus 6x plus 5. I'm going to look for those x-intercepts. Okay, so let's look for those x-intercepts. Pink. -1 and -5. So I get x plus 5 and x plus 1 because we use the opposites. Okay. So in this case, we've had to determine that we had a common denominator. Okay. Once we determined that we had a common denominator, we worked with the numerator, brought it over, and then we now had to factor. Our last step, simplify. Okay, so let's go ahead and simplify. Simplify just means, remember, looking for those common values that are the same. X plus 1 represents a value. X plus 1 represents a value, so they are the same. We can cross them out. We can only cross out from numerator to denominator, okay? And then what we're left with is what is left over, which is 5 over x plus 5. Okay, remember those two 5s cannot cancel because x plus 5 is an entire value. Now, we are going to go to Desmos. We're going to plug this in and we're going to check our work because that's what we do. 6x plus 3 divided by x squared plus 6x plus 5. And then I'm going to put subtraction, and then I'm going to put x minus 2 divided by x squared plus 6x plus 5. And we check our work simply by typing in our answer. 5 divided by x plus 5. And notice what happens. Our original work is exactly the same as our answer, so they are equivalent. So 5 over x plus 5 is going to be the answer in simplified form.